What happens when the most powerful technology on Earth simply runs out of food? For the past decade, artificial intelligence has grown by doing one thing: devouring the public internet. It scraped our blogs, digitized our books, and indexed our social media posts. But researchers at groups like Epoch AI have identified a looming crisis. We are on track to exhaust the entire supply of high-quality, human-generated public text on the web, potentially within the next 3 years. The digital well is running dry. And to survive, artificial intelligence has to look somewhere else, outside the screen and into the physical spaces where we actually live. To understand why tech companies need our physical environments, we have to look at how information itself is changing. In a landmark January 2025 academic paper titled Foundations of GenIR, researchers mapped out a fundamental shift in computer science. We are transitioning away from traditional information retrieval, where a search engine merely points you to a web page, and toward generative information retrieval. Under this new model, AI does not just find documents. It synthesizes a highly customized, immediate answer tailored specifically to you. But to generate answers about your real-world tasks, the AI cannot just read Wikipedia. It needs to know the layout of your home, the coordinates of your objects, and the physical choreography of your daily routine. But why can we not just simulate the real world? For years, AI developers relied on simulated environments to train models. This is called the sim-to-real approach. The problem is what engineers call the reality gap. A simulated room operates under perfect, sterile physics. It does not account for a pet running across the floor, a misplaced toy, or the chaotic, unpredictable way humans move. To build a system that can assist an elderly person, fold laundry, or navigate a cluttered office, the AI must learn from the chaotic reality of physical spaces. The only way to get that data is to harvest it directly from our homes. This physical gold rush is already quietly underway inside your home. Take your smart robotic vacuum. To you, it is a convenient tool that cleans your floors. To an AI developer, it is a mobile physical cartographer. Equipped with LiDAR and optical sensors, these devices generate precise spatial maps of your living spaces. When tech giants attempt to acquire smart appliance manufacturers, the underlying prize is often not the hardware or the immediate sales revenue. The prize is the rich, structural mapping of the private interior spaces of millions of homes. In one notable industry incident, development images taken by test versions of robotic vacuums were even leaked online, revealing the high-resolution reality of what these devices capture inside our private sanctuaries. But mapping the floor layout is only the first step. To understand human behavior, an AI needs to see the world from our exact point of view. This explains the industry-wide rush to popularize smart glasses and spatial headsets. When you wear a pair of camera-equipped glasses while walking, cooking, or talking, the device captures a continuous stream of first-person audio and video. Developers can analyze this data to teach AI models how humans naturally interact with physical objects. The user agreement policies of modern wearables are constantly evolving, quietly expanding the terms under which this ambient, multimodal data can be processed to train future foundation models. Once this raw spatial data is harvested, how is it used? It feeds into massive virtual training platforms, such as Meta's open-source Habitat Sim or modern 3D reconstruction tools like Nerf Studio. These systems take 2D video feeds or spatial maps and turn them into photorealistic, interactive virtual worlds. Inside these digital replicas of real homes, developers run millions of AI training loops at accelerated speeds. A virtual AI agent can practice navigating a real human kitchen 1,000,000 times in a single day, learning how to dodge chairs and find coffee mugs before ever being loaded into a physical robot. It is easy to view this shift as a corporate surveillance plot, but the truth is far more nuanced. There is a profound utility versus privacy trade-off at play. If we want helper robots that can care for the elderly, assistive devices that navigate safely for the visually impaired, or smart prosthetics that adapt to physical environments, those systems must have access to highly detailed physical training data. An AI cannot safely navigate a real hallway if it has only ever trained on textbook files and internet chat rooms. The technology we say we want fundamentally requires the digitization of our analog lives. As we step further into the era of generative information retrieval, The boundary between our online and offline lives is dissolving. Being offline no longer means being untracked. Our living room geometries, our physical movements, and our daily home habits are the new training fuel for the next generation of computing. We do not have to throw away our smart devices, but we must understand their shifting roles. They are no longer just simple appliances serving our convenience. They are active eyes and ears, mapping our physical world to feed an insatiable, data-hungry industry. If you want to retain control, your best tool is awareness. Take a moment to audit your smart device privacy settings and decide exactly how much of your physical reality you are willing to share.